The chapter is the decision control structure, very important chapter. So in our daily life, we always come across decisions. Means if you are following a road and there is a diversion and there is nothing written, you have to take a decision. Which path will take you to destination? If else is the construct we'll see here today. Along with that, we have switch and various others we'll be talking about, but we will concentrating about the if statement, if else statement, and this is a decision control. When you take a decision whether to take this part or that part, or which is true or which is false, we will use if else. What are decisions, and decisions, why they are important? See, we have a program and these are nothing but sequence of instructions only. Now if something happens, something is true, you want to execute these two lines. But if this is not true, you don't want to execute these two lines. You don't want these two lines to run if this condition is not true. For that, the decision control structures are there, and we have if statement, if else statement, and we have conditional operators. We also call it as ternary operator, and this is just the form of if else only. If statement, most of the languages, high level languages, middle level languages, they provide if, that is, if something happens, or if decision control, and the general form is like this. If what you have to do is, inside this if, you have a round bracket, and this if, this is if, inside this round bracket you have a condition. Now this condition either needs to be true or false. If this condition is true, the line which is just next to it is going to execute. Only after this, the line is going to execute. If this condition is false, the condition inside the parenthesis, this line is not going to execute. So this is the only thing, that is the truth or falsity will decide whether the line which is coming has to be executed or not. So how this inside this condition is going to give you true and false, we'll see. We'll use relational operator like x equal to y. If I write if f is equal to y, please understand that is equal to is done through, or equality is checked through double is equal to. So these are those two assignment operators. So if x equal to y means x is equal to y, x not equal to y, x less than y, x greater than y, x less than equal to y, and x greater than or equal to y. So these are relational operator. Relation operator means you, your brother is taller than you. So whether it is true or false, yes, it is true, so it will give true. Now if you are this and your brother is smaller, you say it is false because you are taller than your brother, becomes false. So this will either give you true or it will either give you false. Not equal to, this is equal to, this is not equal to. Whether x is not equal to means 2 is not equal to 3. Yes, it is true. But 2 is not equal to 2. It is false because 2 is actually equal to 2. We'll take an example. This is the demonstration of if statement. Say we have an integer variable num. We have entered, or we want user to enter a number which is less than 10. It should be less than 10. This is less than 10. So we have taken this in num, num. If number is actually less than equal to 10, we say okay, so write something. But if it is not, we'll also see that case. But if does what? If does this thing that this condition, or this is the condition which is going to give you either true or false. If you enter 9, see 9 is less than equal to 10, then it will be true. If somebody enters 100, 100 is not less than equal to 10, so it will give you false. So depending upon true, this line will be executed. If it is false, this line will not be executed. Control will not go to this line. Otherwise, if this is true, control will go to this line. That is the decision control, right? Let us see what is happening in this program through a flowchart. We enter a number or ask a number to enter 10. We input that number. Now, this is our decision control. This is our decision control. Whether number is greater than 10, if it is yes, this line will be printed. Otherwise, if number is not greater than 10, then if it is not, then we don't print that line. We come to this stop condition. Let us take an example. While purchasing certain items, a discount of 10% is offered if the quantity is more than 1000. If the quantity of the item you have purchased, if it is more than 1000, then the 10% discount is, you are eligible for 10% discount. Otherwise not. How to do this? If the quantity and price per item, these are to be inputted using the keyboard, we have to write a program to calculate the total expenses. Now let us see how this if decision control can be employed. First of all, we say dis equal to 0. This is very important. Why we are saying this or discount equal to 0? Because if the number of items being purchased is less than 1000, then we have to put this equal to 0 because there will be no discount. Otherwise, if the item happens to be more than 1000, you have to give a discount. So what you have to do? See, first of all, input the quantity and rate. If this is the decision control, this is where you are going to use if. If the quantity is greater than 1000, if it is yes, then you put discount equal to 10. Otherwise, you said no, that is this discount will be 0 as you have initialized here. Then you will calculate the total. Total will be simply quantity into rate minus quantity into rate into discount percent, this by 100. And then we print the total and we stop. How this is going to be implemented in C? See, we will initialize Q2I means quantity and discount equal to 0. This is very important. You may ask question, is it necessary to give DIS or discount equal to 0? Yes, because this cannot just be left like this. It may contain any garbage value. When you have initialized or when you have given it to be 0, then if the condition fails, that is, the items are less than 1000, then this will be used. How? We will print enter quantity and rate, and this will be, you will be entering or scanning the %D, %F because you have given integer as quantity and the float as rate. Now what is happening here is, this is very important. This is our decision control. This is our decision control. If quantity is greater than 1000, you give a discount equal to 10. If quantity is not greater than 1000, you don't give any discount. This line will never execute if this condition falls. That means if this condition falls, this will be 0. So this part eventually will be of no use because it will be 0. Otherwise, if actually the quantity is greater than 1000, then 10 will come here and you will actually get a discount of 10%. Then you print out the result. See, these are the results. 1200 means the quantity is greater than 1000, you get a discount. If the quantity is less than 1000, that is 200 is the quantity, you don't get a discount. Actually, discount will be 0 as you initialized here. So this is how this program runs, and as I just said, this equal to 0 is quite necessary. It's actually in this program, this is the core of the decision. The real thing here is, if this condition, this can be true or false, as we just saw, some statement will execute. If it is false, this statement is not going to execute. So this is a condition. That means you can even use an expression inside this. That means you have a condition, but there is no restriction. You can have an expression also, but this expression should give you a result as true or false. The result should be either true or false. So what we are trying to do here is, this is an expression. See, 3 plus 2 modulo 5. 3 plus 2 modulo 5. 2 modulo 5. 2 modulo 5 is what? It will be 2. You know, in modulo, if the numerator is smaller than the denominator, you get the numerator by itself in modulo. So you get what? 2. You get 2 here. And 3 plus 2 is 5. And when this is 5, this is going to work. Even if you have 10, it is going to work. If for minus 5, it is going to work. How it is happening? What is the real thing? Real thing is, if 0, then this line will not execute. Otherwise, anything other than 0. It can be 2, it can be 5, it can be minus 999, it can be 55. Anything you give other than 0, this will be treated as true. I hope I am clear. Apart from 0, anything which comes here, apart from 0, if 0 means it is false, the condition is false. If you give any number here, the compiler in C is going to take it as true. I hope you got the idea. 10, 5, minus 5, no worry. Any number 10 or minus 5 or any number here other than 0 will always be true. So any number here will be true except 0. Multiple statements within if. You can have multiple statements. By now we have just seen that our execution was what? If the condition here, then this line. So if this condition is true, this line is going to execute. If the condition is false, this line is not going to execute. But what we are trying to suggest here is that if you want more than one line to be executed, then what you have to do? Because we have just seen only one line will be executed after if. If you want to execute more than one line, the simplest is to put them inside a brace. We'll see an example. The current year and the year in which the employee joined in the organization, they are entered through keyboard. If the number of years for which the employee has served the organization is greater than 3, he gets a bonus of 2500. Otherwise, he won't get anything. If the year of service are not greater than 3, the program should do nothing. See, this is our program. This is bonus, this is current year, this is year of joining, this is year of service. Say somebody entered the current year as 2018 and he entered 2016 as the joining year. What is the difference? What is the difference? Difference is 2. So he won't get any bonus. He won't get any bonus. But if he enters the current year is 2018, he joined in 2013. That means 5 years he has worked. He is eligible to get the bonus. So what we will do here is we'll take the difference of current year and year of joining. We'll enter current year and year of joining, and this year of service will be compared with 3. If it is greater than 3, then we want to execute 2 lines. How to execute 2 lines? We have to give it inside a brace. So these 2 lines are inside the brace. And if it is less than 3, we don't execute these 2 lines. So what was happening here is, we entered the current year and year of joining. Then the year of service can be computed using current year minus year of joining. If at all this year of service is greater than 3, if it is yes, we execute multiple lines, bonus, print, anything you can do. How many lines you want, it's up to you. You can execute 100 lines, no problem with that. If at all the case is not there, that is year of service is less than 3, then there has to be done nothing. The if-else statement. The if-else statement says, if the condition is true, very well, you execute this line. But what if this condition is not true? You want to do something if this condition is not true. That means if this condition is false, then what you need to do? You want to do something. So just put it after else. There is no semicolon after if, there is no semicolon after else. If condition is true, this line will be executed. If this condition is false, then whatever you have written after else will be executed. We'll see this with an example. If you are talking about a company, if in a company an employee is paid like this, if his basic salary is less than 1500, then HRA will be 10% of the basic salary, DA will be 90% of the basic salary. If his salary is either equal to or above 1500, there are 2 cases. If it is less than 1500, HRA and DA is like this. If it is above 1500, HRA is given as 500 and DA will be 98% of the basic salary. If the employee salary is to be inputted through the keyboard, we have to write a program to find the gross salary. How to write it? We will start with float as basic salary, gross salary, DA, DNS allowance and house rent allowance. We'll enter the basic salary. We'll see whether this basic salary is less than 1500. If it is less than 1500, the HRA has to be computed as 10%, 10 by 100 of BS. The DA has to be computed as 90% of the 90 by 100 of BS. Otherwise, if this is not the case, the second case, then you have to execute that case, you have to put an else. See the construct. If this condition, then whatever you want to give inside a brace. Else, the other condition has to be given inside else. HRA will be 500 and DA will be 98% of the basic salary. And whatever comes, you have to compute the gross salary using BS plus HRA plus DA and you just have to print. So what is happening here is, you want to do something. If is BS less than 1500, if it is less than 1500, this is the yes condition. So this goes under if true. Then if this is true, you execute these 2 lines. Else, if this condition is false, no. If this is a yes, you go here. If this is false, you go this side and you execute these 2 lines. That means you put this under else. The condition is true, you execute 2 lines. Condition is false, that means you have to go to the else and you print these 2 lines and you have to compute the addition and print GS. So there are certain points. The group of statement after if up to and not including else, it is called as if block, and the statements after the else, they form the else block. So in if else construct, we have a if block and we have a else block. You also see that else is written exactly below if. This is an indentation. There is a formatting because you can have multiple if else inside if else's. So the indentation or the formatting has to be very clear. See, if you see properly, this A and B in general English, we have given a space here. We have written properly so that you can understand that these 2 are different paragraphs. If I start notice right here, this will not give you an idea that I am trying to emphasize 2 points. This is what I am talking about, that the indentation has to be very specific, very clear in order to make the program well understood. And had there been only one statement, you don't have to put the braces. Braces are put only if you want more than one line to be executed. But if you want to execute one line, you can also place a brace. There is no restriction. Nested if else. Nesting means putting if else inside if else. Means nesting is a condition where you have, say, an example, enter either 1 or 2. You are scanning I now and you are saying if I equal to 1, you write something, you come to else, then you say if else inside this if. So you are nesting this if else inside a else. You can nest this if else inside this also. So this is nesting. We can have multiple if else's inside if else's. So if else construct inside if else construct, you can have the if else inside if you can have if else inside else. So you can have, but there has to be a proper indentation. But as we just said, the number of if else should not be too much, because the program as it goes larger, then the debugging becomes very difficult if you have multiple if else's inside. Means nesting will actually makes, if you have some errors, it will make the debugging or removing the errors quite difficult. Forms of if. There are certain forms of if. The if statement can only not take one form, it have multiple form. Like if condition, just put a one line. If the condition is true, you want multiple line, put it inside the braces. If condition is true, then you do this. Otherwise the condition is false, then you write it below else. If condition is true, you do this, else you do this. You can have multiple lines below if, multiple lines below your else. If the condition is true, you do this, something you have to do, one line if you want to write. Then you have inside else, you can have if, again else, you can have inside this else is if else. There is no boundation. You can also have if the condition is true, you can have if else inside this if. You can have else, you can have just one line. Or either you can have one more if else inside your else. Use of logical operators. We have three logical operators in C, which is AND given by 2 ampersand, and then we have OR, and this is NOT. So AND, OR, NOT, these are three logical operators, and what they do we'll just see in a bit. These two operators, they allow more than two conditions. This can be combined. If you use if you use while, if you use for, all these. In this, we can have these ampersand and OR. We can have multiple way or conditions that can combine to a single output that is true or false, right? We'll see it with an example. That this is a marks obtained by a student in 5 different subjects. This has to be inputted through the keyboard, and the student gets a division as like this. That is percentage which is above or equal to 60. It has to be given first division, between 50-59 second division, and 40-49 third division. And below 40, it should be failed. So how to write a program to calculate the division which is obtained by the student? So there are different ways. First, we'll go ahead with the normal way which we have learned up till now. That is, this is method 1. We are not using the operators here right now, we have discussed. But what we are doing here is, we are taking M1 to M5, the marks. This is percentage. We are inputting the values in %D from M1 to M5. We are adding them, dividing by 5. And allowing it to go to PER. This if PER is greater than or equal to 60, we print first division, else. If PER is greater than or equal to 50, we say second division, else. If PER is greater than 40, we say third division, otherwise we say print fail. So there are multiple if and else's we have used, and this does the job. But this is very straightforward program. We have various if else's here. There are certain disadvantages if we use if else's. More, if you use if else, nested if else, there may be certain things which we have to understand. As the number of conditions go on increasing, the level of indentation also increases. That means the whole program creeps to the right. That means care needs to be exercised to match the corresponding ifs and else. If you lose one brace or one curly bracket, there will be a problem. So you need to care to match the corresponding pair of braces. All these problems can be eliminated if we use the logical operator. Let us see the same program using the logical operator. How? Same thing we have done, taking M1 to M5 and entering these values and finding the PER, that is the percentage, adding the marks and dividing it by 5. Now, if the percentage is greater than 60, we say first division. But now the second one, we know 50 to 59, we have to take a range. What we can do here is, if PER is greater than 50 and PER is less than, that means in AND, if both the condition on left and right hand side, if these are true, then only it is going to give you true. So if both are true, then second division. Then we again check for if between 40 and 50, if both these are true, we say third division, and then if pers is less than 40, we say fail. So same thing we have done with ampersand operator, and the two distinct advantages we see here. First, we don't have to match so many if and else's, and we have various conditions, but still this program becomes more effective than multiple if else's. Else if clause. Else if clause is what? See, we can write a program to enter the marks of 5 students or 5 subjects of a student, add them, divided them by 5 and find out the percentage. Now this percentage can fall in various categories: first, second, third and fail. How to write that program? We can write the program like this. This is a if ladder demo, and we just take from M1 to M5 and add them all, dividing by this is 5. Now what we get here is percentage. So we add them, divide by the value 5. If there are 5 subjects, then we say it is PR. Now percentage, if it is greater than or equal to 60, we say first division. Then rather than putting if, then else, then again if else inside this, again if else inside this, for checking all these conditions, we can use else. So if this is the condition, we print else if percentage greater than 50, second division, else if percentage greater than or equal to 40, third division. So if this condition fails, then it goes to this else. If these both condition fails, then it goes to this. Otherwise, if these condition, all three condition fail, we're going to fail. So you can note here the indentation is very clear, the formatting is very clear, the last else is optional, but the else if has taken its place, and else if is nothing but we are just combining the if else. So just the code you can see here, it is evident that I equal to 2, you print something, else j equal to 2, print something. Now we can combine these. This is nothing but you are combining this else and if. This else and if you are combining and giving it to else if. So you are just reducing the line and making it more clear. Your program look more clear, formatted and understandable. So if I is equal to 2, you print something. Else if j is equal to 2, this else if you have used instead of this else if. There is another place where this logical operator can be very useful. We want to write programs for complicated logic and we have two answers, true or false. If it boils down to true or false, we can employ the logical operators. For example, we have a question: a company insures its drivers in the following case. Driver is unmarried, driver is married. Then driver is unmarried, male and 30 plus, or the driver is unmarried, female and about 25. So in all of the cases, the driver will not be insured. So the marital status, sex and age has to be inputted through keyboard and write a program to determine whether the driver is to be insured or not. How can we use? See, first this is somewhat complicated situation, but we can easily solve it. First, we'll use without using logical operator, and we'll see how this logical operator, if you use, will make the program quite easy. See, first we'll try to show it without using logical operator. We have a char, this is your sex, this is your marital status, you have age. Just enter the age in %d, that is integer, sex and marital status in character. Now, if the marital status is married, we say that driver is insured. Otherwise, if sex is male, age, then we have to check for the age which is greater than 30. If it is greater than 30, he is male and we say driver is insured. If it is not, he is not greater than 30, driver is not insured. We can have one more condition, else. If these two condition fails, we go to else if age is greater than 25, driver is insured. Otherwise, driver is not insured because the sex has to be female, right? So if this condition fails, that means the driver is a female. That is why we come here. Now this again have various braces here, various indentation here. Can we solve it? Can we put some logical operators into use so that we can rewrite this program? Let us write this program in other terms, and here let us make certain cases. The cases are like this: that driver is married, driver is unmarried, male above 30 years, driver is unmarried, female above 25 years. So we have 3 cases in all. Let us use them. We are writing the program using and or operator. So we are taking the char, sex, ms, that is marital status. We are entering the age. Enter age, sex, marital status in these 3 variables. Now, first condition. See, if the marital status is man, or if any of the left or right condition is true, it is going to show you true. Whole is going to show you true. Any of this, both are true, it is true. One of them is true, then it is true. If both are false, then only or will give false. How about and? And will give you, if both are true, then it will give you true, otherwise false. That is, if one is false, false. If this is true, this is false, false. If both are false, false. So what we are trying to do here is, we are putting first condition here, making an or, then the second condition we are placed inside and. So if these 3 condition, any of these is false, it is going to be false. Otherwise, any of these 3 has to be, all of these has to be true. Then only this will be true. Same is the case after this or, all these 3 has to be true to make it true. So we have three conditions, we have the three cases. All these cases we have just put in one line. This one, this one, this one. And if these conditions meet, we say driver is insured, otherwise uninsured. That is how we use the and or. So what we have to see here is that the conditions where we have used the parenthesis we have used, and the parenthesis in and or does this similar trick that on the left hand side and right hand side on the and, if any of these is false, it is going to give you false. In or, any of the left hand side and right hand side is true, it is going to give you true. So what we conclude here is, when it is to be tested whether a value falls within a particular range or not, we use and or. When after testing several conditions, the outcome is only one of the two answers, that is true or false or yes or no, we use and or. So this can be extended to various more operations. Let us take an example. Write a program to calculate the salary as per this table. So we have, let us see, we have male. One condition is male greater than equal to 10 postgraduate and 15,000. Postgraduate will take 0 for graduate, 1 for postgraduate. See, all this condition can be combined in and on operation. How? We are taking the character as G. G, if it is 0, then it is graduate, 1 it will be postgraduate. This is year of service, qualification, salary as per the table. So we want the user to enter the gender, year of service and qualification. So we'll take these values. If the G, that is this one, graduate or postgraduate, is M, year of service is greater than equal to 10 and qualification equal to 1. So qualification, actually this G, qualification is 0 or 1, that is it has to be 0 or 1 for being into graduate or postgraduate. I hope you got the idea. 15,000 said. This gender G is, if G is taken as the gender, we can just equate it with the male. So gender is male, year of service 10, qualification equal to 1, salary 15,000. How? See, gender male greater than equal to 10, year of service, postgraduate 15,000 salary. This is first condition. Again, all the condition can be met like this. Else if gender male, year of service 10, greater than equal to 10, qualification 0, or because we have 10,000 for both of these. So we can combine these conditions in a or. First condition or second condition. If any of these is true, we say salary equal to 10,000. Similar is the case with else if, the second one. So gender male, year of service less than 10, qualification 0, salary 7,000. And similarly for all of them. This is how we use the and or operator. Then we have a not operator. Not operator does what? We have seen the logical operation and or. And or, in this and or, we require condition on the left hand side and right hand side, and we combine them. This result can be true, this can be false, or any of these, and we combine the true and false to get a single true and false, but not actually inverts. So this is like an inverter. When you pass true, it will give you false. When you pass false, it will give you true. So this negates. Basically, it negates. So this operator reverses the result of the expression it operates on. Just for example, if the expression evaluates to some non-zero value, any non-zero value, when you apply the not operator, it will give you 0. So not 5 is 0, not 555 is also 0, not minus 5 is also 0. So the final result after applying this 0 or 1 is considered to be false or true respectively. So we'll take an example. First of all, relational expression. Not y less than 10. So y less than 10, if it is y less than 10, not means not y less. What we are trying to say is y is less than 10. The expression will be false since this is true. If this is true, not means it makes it false. So we can express the same condition like this one. Y less than 10 is equivalent to y greater than equal to 10. So this not operator is used often where we want to reverse the logical value of the single operation. That is, if not flag. This is another way of just saying if flag equal to 0. If not flag means not equal to 0. So it may seem somewhat confusing. So we usually do it when it is really required. Hierarchy of operator. We have already seen the hierarchy. So the first one is the not. In an expression, if you find not, it will be done first, followed by into, division and modulus. Then we have plus and minus, that is arithmetic. Less than, greater than, less than equal to, and greater than equal to relational. Then comes the equal and not equal. Then we have and, then or, and then we have assign. So this is the order of the operators which are going to work when we have, say, an operation, or we have to do operators and operand to find certain value of the expression. There are certain caution you need to understand. First of all, see, this is doing what? This program. Can you find some error here? Or what is going to happen? If I equal to 5, you entered 5. Whatever you enter here, whatever value you enter here, it will always give you this line. Why? This is because you are not equating, you are not trying to find out whether I is equal to 5. we are actually assigning the value of 5 to I. So always this I will be 5. Okay, this will be true. So always this line will be. You have to be very careful with this assignment sign and comparisons. This is what the discussion is, right? One more thing is putting the semicolon. Semicolon means in this particular code, see, you have a semicolon after if I doesn't double equal to 5. Now when you have this double is equal to, that means it is okay. But when you are putting a semicolon after this, that this compiler is understanding that after I equal to double equal to 5, you don't want to do anything. This is a null statement, and you have a null statement. After that you have a semicolon. So this is done. This line has no relationship with this because you have a semicolon. So beware where you put a semicolon. Okay. This is just like this. If I equal to 5 and then semicolon after. So therefore you will always be, you see, when you use for, when you use while, where to put semicolon, where to put colon, this has to be well understood. This summarizes the working of the logical operator. This is x, y. This is not x is 0 becomes 1. Y not y, 0 becomes 1. X and y both are 0 on the side, and will always give you 0 when both are 0, or will give you 0 when both are 0. But any of these non-zero, any of this non-zero, any of this non-zero, x or y will always give you 1, 1, 1. And any of this has 0, 0, then x and y will give you 0. But when both are non-zero, it will give you 1. The conditional operator. Conditional operator, we also call it as a ternary operator. This is very simpler form of if else. This is simply if else. So if the expression 1 is true, expression 2 will be done, otherwise expression 3 will be done. Please see the question mark and this colon. This is how we use it. So this says if expression 1 is true, then the value returned will be expression 2, otherwise expression 3 will be returned. We'll see an example. If xy, scanf %d ampersand x. If x is greater than 5, if you enter a value which is greater than 5, 3 will be assigned to y. Otherwise 4 will be assigned. That is similar. This one line is similar to saying if x is greater than 5, y equal to 3, else y equal to 5. So these two are similar. We have one more example. You can put a condition is here also, means logical operations also here. So say you scan something, you say a between 65 and 90. You assign 1. If it is not between 65 and 90, you assign. There are certain points where you need to understand. It is not always necessary that the conditional operator should be only in arithmetic statement. You can also have printf or any operation which is possible in as a statement. So we have int I scanf. You are inputting some I. If I equal to 1, you print Amit. Otherwise, you print all and sundry. If a is z, you can also put this ternary operator or conditional operator inside a printf. So now putting inside the printf. If a is greater than this, you assign a, so a will be printed, otherwise exclamation mark will be printed. This conditional operator can also be nested, so a greater than b. Again, you will get a result from here, you get a result from here. So this is already nesting. This is one more problem is there. If you do or write this, you'll get a L value required. That means logical value is required. Why? You have to put this in the round brackets, because what here compiler assumes is, if you're not giving the round bracket, that means the compiler will see that this b is being assigned to the result of the expression of the left of the second is equal to, and it reports an error. So just making or putting the parenthesis will solve this issue. Let us summarize what we have seen. There are 3 ways of taking decision in a program. If else, we'll see second way is to use the conditional operator, and we have a switch statement. We'll study about this switch, etc. We have seen if else here. The default scope of if is only the next line. So if you want to execute more than one line, you have to put those lines inside your braces. The if block need always be associated with an else block? No, it is not all. But an else has to be. An else block is always associated with an if statement. If the outcome of the if else ladder is only one of the two, answer yes or no, the ladder could be easily replaced with else if or by the logical operators. The and or, these are binary operators. This exclamation, it is not operator, it is a unary operator. These, they require at least two expressions or values. This only require one. So if in C every test expression is evaluated in terms of 0. All other values apart from 0 they are non. Assignment statement used with conditional operator must be enclosed within pair of parentheses. Okay, so this is all about this chapter, that is the decision control. Thank you so much. Take care of yourself.